Hi everyone, welcome to this Python quick course. So in this course we are going to approach the basics of Python, and I hope that by the end of it you'll be pretty excited to learn this programming language and continue to learn this programming language. Of course, it's going to be impossible to teach you everything about Python in 2 hours, but I hope that these 2 hours will be enough for you to understand how the basics of the language work. Also by the end we'll have some coding exercises and quizzes for you to practice. This course will be completely free, and I'll keep it completely free because I just want to give a first introduction for people that don't have that much time, just need to understand how Python works on a high level without any investment and with a few investment in their personal time, which is of course something very valuable. So here in this course we are going to learn basically the most important Python objects, also learn how we can deal with Python data types and what do they mean. We'll have our first introduction into Python functions and control flow, and we'll also understand the most important libraries. You'll understand what this means during the course that one can use in this open source language. You don't have to pay anything to use Python. It's a completely open source and free language. This should be a pretty cool and not expensive journey. So I hope you're excited as I am. So my name is Ivo. I'm here to be your teacher in this course, and I hope you really enjoy it. Let me know your feedback and your comments. If you need any help, just send me a message. I'll be happy to try to support you in your learning journey. Without further ado, let's start to learn Python. I'll see you during the course. Hi everyone, welcome to this Python course. So let's start by setting up our environment so that our computer can run Python code. That's the first thing that we need before we start to code in Python, of course. So again, as I said in the introduction, there are 2 ways that you can follow to run the materials in this course. One of them is setting up your computer to be able to interpret Python code. Windows machines by default can't interpret Python code, although Mac or Ubuntu machines, for example, or Linux machines can interpret Python code off the bat. Although here for beginners we are going to use the Anaconda distribution, so if you have a Mac or an Ubuntu you can also set up the Anaconda distribution on your systems as well. The Anaconda distribution is like a more easy way and user-friendly way for beginners to understand how they can run Python code in their machine instead of just installing Python native. The other alternative that we have, and if you want to go there you just skip to the last lecture of this section, is to run Python code using Google Colab notebooks. So Google Colab notebooks are basically ways for you to run Python code in the cloud directly without having to set up anything in your computer. You just need a Google Drive folder. I'll show that as well in the last lecture of this section. If you don't want to set up Python in your computer, you can skip until the last lecture where I have the lecture titled Google Colab Notebook Setup or Google Colab Notebook Environment. So let's start by downloading Anaconda distribution and setting it up in our environment. Here in Google you can just do Anaconda distribution. This would go for here for the first. I'm going even to put Anaconda distribution download. This, and then we are going for the first link that we see on Google. This will open this window right here. You can hit download here on this icon. This will basically download a file, an installer file, just like any Windows file of the Anaconda distribution, enable you to have the Anaconda navigator in your computer. So hit download and this will start to download the file. When this download finishes, you can go to your usual downloads folder and we'll see what we have there. When the download is completed, go to your usual downloads folder and you can see here an icon similar to this one. I'm going to double click it and this will basically open a common file installer or a software installer here in Windows. I'll also leave some resources on how you can install Anaconda distribution in Mac or Ubuntu. Okay, so let's just wait for the installer process to open and there you go. Now I'm going to hit next here on this one. I've already read the license, so after you've read the license you can hit I agree. And here you can install for just you or for all users. So I'm just going to use just me. I'm just the user of my computer, but I could also hit all users. And then you can just hit where's the destination folder. I'm going to leave the default one, hit next. And then here I'm going to do something. I'm going to register Anaconda as my default Python 3.9. And I'm going to add Anaconda 3 to my path environment variable. Add it to your own risk. It may cause some interference if you have installed Conda or Python before. If you have not, probably there's not going to be many things bad. There's not going to be bad things coming out from checking this box. I'm going to use it, and this will enable me to run conda commands via the command line, as I'm going to show you next. I'm going to hit install, and this should install the Anaconda distribution in my computer. Let's just wait for the install process to finish, and then we'll return to see how we can open the Anaconda Navigator in our computer. So when this install process is complete, you can hit next, and then hit next here, and then you can start immediately to have the Anaconda distribution tutorial, or getting started with Anaconda if you want to go through those tutorials as well, and then just hit finish. So now we have Anaconda in our computer, and we can interpret also Python code in our computer. So now if you go here to the Windows search and search for Anaconda, you should have Anaconda prompt and Anaconda Navigator. What I'm going to do is to open Anaconda Navigator. You can also find, maybe you also have it on the desktop or a desktop icon. Here, also through the search bar, you'll end up in the Anaconda Navigator. Now let's wait a bit for our Anaconda Navigator to start, and when Anaconda Navigator starts, we are going to be able to see the environments and all the stuff that we will need for this course. After a while, Anaconda will open and you'll have this window on your computer. In this side, you'll have several things that you can do in Anaconda, and here you have several services that you can launch using Anaconda, including some cloud platform environments and all other stuff. What we'll use throughout this course is Jupyter Notebooks, a notebook environment for us to code in Python, which is a very good platform for teaching, and also a very good platform to understand and write some code with scripts and to explain the code that we are doing. Hi everyone, welcome to this Python quick course. Okay, so for this quick course, we are just going to use an environment that we can use to load our libraries and stuff that we may need for this Python quick course. Okay, so don't need to worry too much about it. This is just a way for us to access certain libraries that we will see what they are in the course using Python. So super simple. If you follow the route of using the Anaconda Navigator, which will basically let you install Python in your computer, you just go here. You will not have these data science and NLP course that you have here, because these are other environments that are used for other projects that I have. But you'll just probably have this base root after installing the Anaconda Navigator. Now what you can do is go to import. In the local drive, you navigate to the course materials that I've given in the resources, and here in the course materials you'll have this Python quickcourse.yaml file. Okay, here just super simple, you just have to double click this and then just wait a bit for this import to be available and click import, and wait a bit for Python to create this new environment. Okay, so the environment is very, very simple. This is just a self-contained way for us to have the libraries just for this specific course activated. Okay, nothing more than that. If you follow the Google Colab route, you don't need to worry about this, because you can also run code inside the Google Collaboratory, as I will show in the next lecture. Let's just wait a couple of minutes for our environment to be created here in the Anaconda Navigator, and I'll show you how we can launch Jupyter Notebooks in a bit. Alright, so just finished, right? How do we know that? Well, basically that blue bar that was here disappeared. This took around 10 minutes in my system, may take longer or less in yours. And now we have here a play button, meaning that the Python quick course is activated. How do we start to code? And we'll have a Jupyter Notebook overview in a moment. We just go to Home and you hit here, Launch a Notebook. Now this will launch a new notebook that will be able to access code in Python. Okay, the Jupyter Notebook uses basically your browser as a way to communicate with the computer. This will open a new browser page, and as you can see, when you are here, you'll be able to visualize a file explorer here, just like Windows. In the Jupyter Notebook overview, we'll navigate this with more detail. Okay, just want you to know that now we are inside the environment that we will use to code in these lectures. Use this Python quick course so that we are working on that environment, and you can confirm that you are working on the environment by going here, new. If you have here just Python 3, you can open that Python 3 all the same. It will work on your environment. If you have other conda envs here, just open the conda env that you want to work on. In this case, I want to work on Python quick course. Just to recap, you can have here only Python 3 because you only have one environment, and that will show up. As I have more environments and I have other stuff installed on my computer, I have these condaeums as well. So if you open Python 3 is exactly the same for your case as me opening the Python quick course. I'll go here and then you can try to do the following. Import pandas here on the first line. Then you hit a shift enter or run. Okay, let's see what will happen. As you can see, no error. So if we had like something here on the output, we would have an error. We don't have, that means that we can import pandas in our environment. Everything is okay. We are ready to tackle Python. Okay, let's go and go for the section where we will start to code. I'm not going to give an overview on Jupyter right here. This was just for setting up the environment. We'll have time to do that in the next section, and that's where we are going to start. I'll see you in the next lecture. Hi everyone, welcome back to this course. So if you want to follow the Google Collaboratory way, you just have to have a Gmail account, basically a Google account where you can put folders inside that Google account. You drag the files inside the folder. For instance, I have this Python quick course. On your case, you can be on another one of my courses, such as the NLP course or the Python for Absolute Beginners course. Doesn't matter. You just grab the resources that I've given you and you put them inside Google Drive. You upload them to Google Drive. Okay? As soon as you have them on Google Drive, you can go for the notebook. I have here one notebook file that I can even see here on the details. As you can see, every file that has YPYNB as an extension is a notebook file, and I can double click it. This will open a Google Colab environment. If you don't have Google Colab associated with your account, you'll probably be asked to download Google Colab into your Google Drive environment. That's also one of the ways to do it. So now, for example, I've opened this Jupyter Notebook overview, and you'll have other notebooks that you can use throughout the courses that I'm giving, and you can just go here and use this to execute each part of the code. Okay, so if I'm here, instead of, and when we have the Jupyter Notebook overview, you'll see how we can run code, but instead of running code inside Jupyter, you'll run it here on Google Colab environment. For example, 1+1, let me also zoom in on this one. 1+1, if I do run with shift enter or control enter, this code will execute and I'll have in the output 2. Don't worry too much about this because we'll have on our overview, on our Jupyter Notebook overview, we'll go through this in more detail, okay, in terms of the notebook environment. The most important thing is that you understand that you can also use this way on the cloud to run code. You don't need to have Anaconda installed at all to run code here on Google Colab. It's just another way for you to run code with a small disadvantage. Sometimes the code that I'm showing, because I'm using Jupyter Notebooks in the lectures, I have certain library versions that have a result. And sometimes the result here on the Google Colab may be slightly different because of the version of the library. That's the only disadvantage, and of course the fact that you have to have a Google Drive. On the positive side, it's way more simpler because you don't need to set up Python on your computer. You can just go here and run. You can also run code using this play button right here that will run your code and give you an output. Also, if we are using some of the libraries that are not available in Google Colab in the course and you need to install them here, you can open a new code cell here, preferably in the start of the notebook, and you can do the following: exclamation mark and then pip install the name of the library that we are working on and that you can access here, because most machine learning and data science libraries are already available in Google Colab. Some special ones may not be, but for instance, if I want to install the pandas library here on the notebook, I would do it in this way, although pandas is already in the base environment of Google Colab. I'm just going to show you that you can do this. This will tell me pandas is already installed, basically requirement already satisfied. But even so, you now know that you can also run code inside the Google Colab environment, and it's probably a bit easier than setting up your own environment. Either way, it's okay, as long as you can run code with the libraries during the lectures. We are fine. Let me know if you have any question regarding this, and let's start with our code. I'll see you in the next section. Hello everyone, and welcome to this course. So first things first, let's start to get familiar with our Jupyter environment and with our notebook environment. And here we are going to first go slow on understanding how the notebook environment works. If you ended up going through the Google Colab version or the Google Colab setup, the idea is very similar to how we are going to use Jupyter Notebooks here. In Google Colab Notebooks, the way that you run code is pretty similar, although the buttons that I'm going to show here may be a bit different on the user interface. The logic behind how you run code and how you add comments is exactly the same. Okay, so what we'll want to do is go here to our environments. In this case, I'm going to use the Python Quick Course environment, but if you are using the NLP course or if you are using any other of my courses and you are seeing these lectures in the context of those courses, you can use the environments for those courses, because mostly here we'll just experiment with pandas and numpy, and honestly I have pandas and numpy in all the environments that I do for these courses, so no issue at all. If you are running on Google Colab, you will be using Google's own environment to run code, and that environment already has the libraries, at least for the introductory section that we are having right here. So I'm going to use this Python Quick Course, which is my 2-hour basic Python course that's also included in some of the other courses that I have. And I'm going to activate this environment. So this must be done before I launch any type of Jupyter Notebook in my computer. Okay, so let's just activate the environment, and after a while it will be activated and confirmed by having this play button right here. Now I'm going to home, and I'm going to use launch a notebook. This will open a browser, in this case your default browser if you have Microsoft Edge, Safari, Firefox. In this case I have Google Chrome, so my notebook environment, so launching a Jupyter Notebook will immediately open, here it is, a new browser web page with the user interface of Jupyter Notebook. I also have here this extra tab that I had before I closed browser, so I'm going to take it out. You can also have other tabs. If you had already Chrome open, when you hit Launch Notebook, this will open just a new tab in your browser. Okay, now there are several things that we can do here. This, as we can see here, is a file explorer. So we have a file explorer similar to Windows and with the same folders that you have in your Windows environment. For Mac or Linux, this will be pretty similar as well, though you will have the folders that you have in that operating system, but the logic is always the same. So now what I'm going to do is navigate to where I have the course materials. I've left a Google Drive folder with the course materials. If you are going to use Jupyter Notebook, you have to download those files into your local computer and put them somewhere. In my case, those files are on my Google Drive, and I'm going to show it in the Windows Explorer. So right now I have these files inside this Python Quick Course. At the moment, I just have here the first notebook that I'm recording right now, but in the course materials, we'll have all the notebooks available for this quick course, okay, and for this section. So pick up the course materials, you go to the Google Drive that I've given you in the resources, you pick up all the folders that you have there, or you download the entire folders, you put them in your documents, for example, or anywhere that you want, and then you can access these YPYNB files via Jupyter Notebook. These are called notebook files. I'm going to do something now. I'm going to simulate what you will do, for example, in your case, if you have these files in your documents. So I'm going to go here, I'm going to take out the Python Quick Course, and I'm going to put it here in my documents. Okay, so as you can see, I've copied that folder that I had on my Google Drive and I sent it to the documents. And here we have the Python Quick Course. Now if I go here, I know that if I go to documents, I should have here a new folder called Python Quick Course. I'm going to use that folder to launch our notebooks. I'm going to have here the files that we are going to work on. Okay, now as you can see, I have the Python Quick Course YAML, which is the environment that I have for this Python Quick Course. You may have loaded another environment according to the course that you are doing, of course, but I'm going here for Jupyter Notebook Overview. Okay, I'm going to open this one, and this will be the notebook that we will follow throughout this lecture, this first lecture. So recap, you navigate into the course materials, you open these YPYNB notebooks where you have the code that we will execute throughout In this case, this lecture is going to be Jupyter Notebook Overview. I'll specifically tell you what are the other notebooks that we will work on, but everything will be inside this Python quick course. In your case, if you are doing this course inside another course, then you'll have a folder just calling section 1 Python quick course, and you can take it from there as well. Now, we have Jupyter Notebook Overview. I've already opened it. And this is the type of notebook or notebook environment that I have. In Google Colab, it should be pretty similar. Now, we can create new notebooks here. If you want to create a notebook for yourself, you can go here, New, select. If you only have Python 3 IPyKernel, you can select that one. If you have more examples, then it's because you have more environments or you already have other configurations. You can open the notebook on the environment that you want to work on, and then you can start to code in there. This will open a completely blank notebook that got saved here in this folder with the untitled.ypynb. I'm going to change the name of this notebook, and I can change it here on the top, and I'm going to call it Working Notebook. Should be the notebook that we'll be using throughout this section, okay? And I'm going to go here, and now you know that this working notebook has been changed, the name of it. Again, recall that I'm on the documents. Now, here on the notebook, let's look a bit into how this environment works, into how this notebook environment really works and how it interacts with Python code. So first thing is that this notebook environment is oriented to cells. These cells are what are able to interpret Python code and give us a return of the instructions that we code in Python. And you can see here that this is a notebook cell. It normally has this in before. In Google Colab, you have a way to go to insert code cell, and you will insert the code cell as well that does exactly the same thing. Now here I'm going to do, for example, 1 plus 1. This is Python code. We can do mathematical operations as we will see in Python. And now if I do run, and run can be done by clicking on this button, run cell, or doing Control Enter. Okay, it's also another way for us to run this code. So with Control Enter, we can run this cell, and we see now an out cell, which is the return of this instruction with the value 2. 1 plus 1, we've run Python code, we return 2. Another important thing, I can add more cells by using this plus. Insert cell below, this will insert me a new notebook cell, and I can go here and do, for example, another piece of code, 2 plus 2, and this will execute this code with 4. Notice that I've only executed this line. If I want to execute both lines at the same time, I can use Shift and select the lines, just like how I select two different files in the Windows Explorer, and then hit run. For example, this will run both cells at the same time. Okay, hope this was clear. Notice that now the in and the out change this number because this is the number of executions or different code or different executions that we are telling Python to run. If I run this now again, just this cell, I'll have a 7 because this is the 7th time that I've submitted code in the notebook. Just know that this is also a way for us to visualize how many lines we've already executed in this notebook. Now, another thing that we can also do is that we can change the type of cell that we have in the notebooks. For instance, if I go to the notebook that I'm giving you, you see here text, right? This text is not interpreted as code. That means that this cell, if I write here some random text, hi and welcome to the Python quick course, this will give me an error. Why? Because this is not valid Python code. So how can I write plain text and not plain text in the context of Python, because those are string variables that we'll see next, but more like plain text to communicate with the reader that's seeing my notebook? That's easy. I go here, select this cell, and change here to Markdown. Okay, changing it to Markdown, notice that the in disappeared. This is a nudge telling me this is not code, this is not going to be interpreted as code, but it's going to be interpreted as text. If I hit run on this cell, what I do is really writing a paragraph in this notebook, but this is never interpreted as Python code, nor is trying to be interpreted as such, and will not interact as Python code. So these are the two most important types of cells that we have in notebooks. We can also have headings that can be changed here to headings, and this will give me, okay, so give me a higher title like in HTML H1 or something like that. So a higher title, and this heading can also be given by giving an hashtag before the text that we are writing. Again, this is not code. This is pure text, normally called in this context Markdown. I'm going to remove this, and this will again write with a smaller font. I'm just going to leave it here. We also have raw NB convert, but don't worry about it. No need to take a look into that right now. So another thing that we can do, we can also run text inside code. Okay, we can manipulate strings and characters, and I'll intertwine between these two terms, but they normally refer to written text, not numbers, not variables as we will see, but written text. We can also do it by providing here inside Python with a single or double quotes, and I can do the typical or classic hello world. And we can have our cell return stuff, okay, in multiple ways. This first way, where we just do this and we have an out, a return from the cell, but we can also print this hello world, oops, here, which in notebook context, it's kind of the same thing. You don't need to worry with the difference between these two things right now. You know that when you don't put a print, you'll get the return of the cell, and you visualize the return of the cell. With print, you print something from the cell. This is important because, for example, if I have two lines of code, hello world 2, and I don't provide prints, I only have the last instruction in the case of the return, because cells in the context of Jupyter can have multiple Python instructions inside one cell. That's completely okay and valid. If I have multiple prints, now that's something a bit different, because if I do print hello world, next line print hello world 2, I'll have hello world and hello world 2. Okay, this is just a small difference, but I want you to pause the video and understand what's happening here, and also to do your tests using notebooks. So here we are doing first line of code, second line of code, and we are returning the last line of code. Here we are doing a print to the user with this hello world and hello world 2, and in this case we are using again a new line to state a new Python instruction. That's completely okay. When we open a new line, we are basically opening a new Python instruction, maybe or maybe not related to the instruction above. In this case, both instructions are not related. They don't depend on each other, but they may depend, as we will see in the future. Now, I think this is the basic on notebooks, and what you can also do is go here to the notebook that I've provided. You can go here through this text that you see here. If you double click on this text, you'll see that you have written code right here. The BR is basically markdown code for a new line. You also have here other stuff that you can explore, and you have here 2 lines of code just like we described. Go to this notebook, play around, try to do your own code here inside the cells, or that you can open a new cell here. And now finally you can also save. I'm going to return to our working notebook, and you can also save the notebook by save and checkpoint. This is it. Notebook is saved on your disk. I'm going to close it. I'm also going to close this one for now. And now I'm going to do something, which is shut down the kernel here. I'm going to explain this in a minute. But now if I open again my working notebook, remember I just saved it and closed it. If I go here to my working notebook, I have exactly the same thing that I've written in the past. Now, why did I run that kernel shutdown? So that will be important when we work with variables, but mostly Python notebooks are oriented to kernels. Kernels are basically sessions that are up or that we can put down in certain scenarios. Normally, if we have variables that we want to save in our Python session, shutting down the kernel, or for example, shutdown, will make variables disappear from the environment, and we need to execute the code again. This will be more clear when we use variables for the first time. And if I go here right now, what we have is basically this notebook running. I can shut down the kernel by going here and doing shutdown. And this will shut down the kernel, and you'll see, whoops, no kernel, which basically means I don't have a way to run Python code because my environment is not up. Can you put it up, please? And I can try restarting now. This will restart the kernel and even give me a new session to run Python code. Okay, when I shut down the kernel, I basically break the connection between Jupyter notebooks and what interprets Python in your computer, and then I won't be able to run Python code and the notebook will complain immediately. Okay, I think this is it for the notebook overview. Let's go for the next lecture, where we are going to start to deal with more things on Python, particularly how we can deal with integer, float, we'll see that in a minute, and strings here in Python. So let's go for that. I'll see you in the next lecture. Hi everyone, welcome back to this Python Basics course. Okay, so now that we had here our overview in Jupyter Notebook, let's start to understand how the Python language works. I'm going to continue here on the working notebook, but if you want to follow along what I'm going to say right now, you can open this 2 Python Basic Elements notebook that I'll be following throughout the next couple of lectures. Now, Python is divided into objects, and we'll understand what this means in a moment. But for now, let's consider, in rough simplification, that objects have a specific type, have a specific data type, and that data type is what enables us to apply certain types of operations to those objects. I'm going to start by describing the most atomic data types that Python has. This is not an official term, but it's a way that I like to use to explain how Python works. So the atomic data types are data types that can't contain any other data type inside it. And these are numbers, such as integers or floats, strings, as for example pure text, and also booleans that we'll see in a moment with true or false. There are other data types that are a bit more complex and that can contain the aforementioned. For example, lists, dictionaries, sets, or tuples. That's something that we will see throughout this section as well. Let's start with numbers. I'm going there to the working notebook and I'm going to open here. Notice that what I'm going to do, I'm going to turn this into a markdown. I'm going to use an hashtag that will give me the heading. I can also write and then go here and change to heading. And I'm going to say Python integers and floats. Integers and floats are basically numbers. I can write here 100, and this is a Python number. If I do 100, Python will return me 100. Now, one of the most important things here in Python is that we can write something in this way, or we can save elements or objects in variables. Variables can be called by name. For example, number. So I want this number that I'm writing to have the value 100. How can I do that? Super simple in Python. Equal sign. This is normally called the assignment. We are assigning the number 100 to this variable called number. Don't confuse this with pure text, because pure text is this. Python even changes the color of the text when we are doing it to let us know that this is indeed a different number. It's something that we are writing, but that is being interpreted as text. If I take out the quotes, I'm interpreting this as a variable. Now, some rules for variables. Variables can't have, for example, spaces. I can do number 1. This is not a valid Python syntax. If I want to call it number 1, I have to put an underscore. I can't use also an hyphen. I just can use underscore in the variable names. Otherwise, to variable names, I have to collapse everything together so that I can call this a Python variable. Now let me run this number is equal to 100. I've just assigned the number 100 to the variable number. Now something interesting, I can go here and I can do print number. Can you guess what this will give me? Let's see. Exactly the value 100. Very cool. We've just assigned a specific number, in this case the number 100, to a variable number. Now, can I only assign these values that I see right here, like a specific number? No, I can assign calculations, for example. 100 divided by 2. And let's run this, and let's now print number. I have 50, the result from this calculation. So I've just assigned the calculation that is on the right side of the equal to the variable number that is on the left side, in this case number. And this number now stores 50. Now notice something interesting. 50.0 was the print. Why? Because when we apply a division, basically Python turns the object into a float. A float means that a specific object is treated as a decimal. So it has some decimal point somewhere in how it is stored. In this case, although we have 50.0, this is treated as a decimal number because it's not 50, just 50. If it was just 50, we would have an integer. For example, if I go here and write 50, and now print this, I'll have a 50 without a 0. But every time we apply the division operator, we are turning the number, even though if it's an integer, to a float number. How can I confirm if something is an integer or a float? I can use the type function that I'll explain in a bit. But now, I can also do other stuff. For example, multiplication is done using the asterisk. Now, of course, if I print number, I'll have 200 in a return. With the multiplication, the conversion to a float doesn't happen. This variable is still an integer. And now I can also sum, for example, 100 plus 2, 102. And I can, of course, subtract 100 minus 2, 98. So see that when I write this code again, the variable is rewritten. Right now it contains, and I can go here and write or run this print multiple times. It will always contain 98 because I'm only running the print. But when I run the assignment again, for example, 100 plus 2, now the print will change. So the variable will retain the value I've last assigned it until I run the assignment again. The assignment will basically substitute what this number means, and by number I mean the variable with the name number that we can call along our code. This is very interesting because imagine that I have a really complex calculation. I'm going to make up a lot of numbers here, for example. Imagine that this is something that I want to represent in some way. It would be extremely tiring if I had to write these numbers every time. So maybe I just want to apply this calculation several times throughout my code. Let's imagine that this is the case, and I can just call this number everywhere that I want instead of writing this whole code that I have here. Okay, and let me just do something a bit different. Okay, this is better so that we don't have that E, that scientific notation. Don't have to worry about that right now. But basically, if I don't want to write this big train of code multiple times, I can store it in a variable, and variables are also interesting for many other scenarios that we'll see in a moment. Now let's start by using Python as a calculator. I'm not going to use the variable assignment that we are doing right now. We are just going to use code here without assigning this to any variable because it's exactly the same. Okay, this 26 is exactly the same as if I will save it in 1 plus 25. Okay, oops, sorry, 1 here, 1 plus 25, and I can do this and use result here, or I can even use, remember that we can run code in multiple lines here, so I can do this. This is exactly the same. Okay, this is the same as doing this. It's exactly the same, although we are not using the result right here. But notice that what we are doing is substituting this 1 plus 25 with the name result, and then we can call the name result that will have exactly the same as if we run 1 plus 25. Okay, just recall this on assignment. I'm going to delete these cells, going to cut them, they will be deleted. Okay, cut them. Now let's do Python as a calculator. So 20 plus 25, in this case, an example. Another example, 25 plus 50, it's another example, 75. I can use, for example, Python conveys with all the mathematical rules that we know. For instance, 25 plus 25 times 10. So as we have the parentheses, the order of operations is respected. The sum will be done first, and then the multiplication will be applied because of the parentheses. Let's see the result of this calculation, 500. But if I take out these parentheses that we have right here, we have 275, because the multiplication is applied first due to mathematical rules, then the sum operation that we have here. Okay, so everything that you know from the mathematical world is applied here in Python. Of course, we can only do calculations with float types of numbers. 1.5 plus 1.8, is 3.3. Now we are not using integer numbers, we are using float type numbers that have decimal points to have this decimal result 3.3 in the return. So let's see how I can check if a number is an integer or a float. We can use this type function right here. Let me zoom this in a bit. I hope you could see everything that I was doing before, but zooming this will probably improve the readability of what you are seeing right now. So I have this type right now, and inside this type I can pass any Python object. I can pass a 25, which is an integer object, and if I do this, I have as a return int from integer. I can pass 25.3, which will return me a float, which is this decimal point. And do you think we can pass variable names inside it? Let's test. I'm going to do first the following. Number is equal to 25.4, and then I'm going to call type number. This is executed sequentially, okay? The assignment runs first, and the type will run second. Again, this is exactly the same as having this, for example, running this cell first and this cell next. I'm just saving time and have the two lines of code in the same cell much better. So if I do number type number, this works perfectly fine. What we have is the data type that we have stored inside this variable number. This is very, very important, because if I go here, let me take out the .4 part, see that the type right now is an integer. So Python is able to understand what's the underlying data type that we have saved in a variable, in these variables right here. That's very, very handy and very, very practical. Now we have also other atomic data types, for example, type ABC string str, and then we also have, for example, true, which is a bool. Now notice, true has the first letter in uppercase. This is the syntax. Python is case sensitive. That means that you must respect the upper and lowercase letters in most scenarios. For example, this true is different from true with everything lowercase. This true lowercase doesn't exist at all. If we assign a variable to this, it will exist, but for starters, it doesn't exist. And notice that Python even give me that information, because when I put it in uppercase, I have this with green font. When I take it out, I have it in a black font, meaning that it is not being interpreted as a Python special case. So this true is basically a bool. The other part that we have is a false, which is also a bool. Okay, I hope this was clear for a first lecture in approaching Python. Experiment around with all this code that I've been showing right here. Do your own instructions, run your own code, and feel free to navigate here on the code, going back and forth. That will give you a pretty good view of how Python works. Next, we're going to see how we can apply more complex mathematical operations in this exercise of using Python as a calculator. This will be the first stretch towards expanding Python, and we'll see that in the next lecture. I'll see you there. Hello everyone, welcome back to this Python course. So we've seen here in the past lectures how we can use Python as a calculator and how we can access certain types of mathematical operations, such as summing numbers, subtracting, dividing, or multiplying numbers. So the most basic operations that we have from the mathematical world. But there are also other types of functions that we may use in the mathematical world, for example, a square root of a number, or applying a logarithm, for example. Those functions can also be used here in Python, and here is where we are going to have our first approach into a Python library. A Python library is basically a set of code that we can access using the import statement. I'm going to write here on Markdown, so Python libraries using math example. So there are Python libraries that we need to install and that are not immediately installed when you install Python, such as pandas or numpy, as we will see. And there are other libraries that are already installed as soon as we set up Python. In this case, if you use Anaconda, as soon as you install Anaconda in your computer. One of those libraries is the math library that we can use using import space math. So the math library enables us to access very cool things, such as functions from the mathematical world, and also certain numbers or special numbers that we can access And in this case, in the context of Python, they are called attributes. Okay, we are accessing attributes of this library. Let's imagine that I would like to have here a function that would calculate me the square root of a number. I can do, for example, sqrt for square root, but if I try to do this, sqrt9 passing a number inside, I'll have an error here in Python because Python doesn't understand what this sqrt is. But as this function comes from the math library, I need to call it explicitly from that library. And I do that using math.sqrt. There are certain functions that we can use, such as type right here that we've used to extract a type of a specific object, or even a print. And a function is defined when we write something and we open close parentheses next to it, being able to call arguments in that function. These functions that we do right here, they are functions from the base Python, so they are not attached to any special library and we don't need to import anything to work with them. These ones, the ones that have import, we need to import them explicitly and we need to call the functions using, in this case, the name of the library dot the function that we want to call. In our case, we know that sqrt is inside the math library. If we run this, there you go, 3 is the return from this function. Let's see if you remember this. If I put here result is equal to math.sqrt9, what do you think that result will have after you execute this code? Pause the video, do it for yourself, and see if you can answer this question. So let's see. I'm going to run this one, and now I'm going to see the result. I can even print it. So the result has, of course, stored what I have assigned into the result variable. So I can assign numbers, mathematical calculations, other functions. I can use all of this flexibility in the Python language to pass values around. So in this case, result now contains the square root of the number 9, because that's exactly what I've done using the math.sqrt. Two important things regarding libraries. So this will only execute after I execute the import statement here on my notebook. For example, I'm going to restart the kernel. Remember that restarting the kernel is shutting down our bridge between the notebook and Python and rebuilding it again. So I'm going to restart, and that means that all the code now needs to be executed. For example, result doesn't exist anymore in my code because I haven't executed it after I've restarted the kernel. Every time I restart the kernel, for example, when you close the Anaconda Navigator and you open it again and launch a notebook again, you are basically also restarting the kernel, although even a bit more seriously because you are even closing Navigator, because you are even closing the Anaconda Navigator. Now, this result doesn't exist. Let's try to execute it using the result math.sqrt. Now we have an issue. Math is not defined. Why? Because we didn't run the import math code. So to make the functions of this library accessible for us in our environment, we need to execute this piece of code, import math, every time we open a new kernel. Either it is because we've restarted it, we've just shut it down, or we've opened our notebook for the first time in the Anaconda session. Because of this, the best practice when you work with Python is to put libraries on the top of your script. Either a Python script that you already are working with, or in the notebook format, this line should be here as the first code. Because in that way, there's two things. You will normally run that piece of code the first time, because you run the notebook sequentially most of the times, and also you can let the reader know what are the libraries that your notebook expects. That's also very important. Although here, just for educational purposes, I'm keeping this library right here so that you can see how we import it and then we pick it up later. Okay, so here now I've run import math. So I have math accessible in my kernel, in my environment. When I'm saying kernel, treat it like an instance of the environment that we have that enables our notebook to speak with the computer using Python code. Interpret it in this way. It's an analogy that you can use and probably, or use any other analogy that you think that will make you understand this question of having some place where you need to execute Python code and translate it to your computer, which is what we are doing right here. In this case, the notebook is just an interface for us to interact with that environment, with that Python kernel that is able to read and understand Python code and send it in a binary way to our computer, okay, so to machine language. This is probably just a bit too technical. Don't worry if you are not understanding it. Just the most important part is that you understand that this is an interface that we are using with a Python kernel or a Python environment in the background. Now, as we are here, I'm going to run result. Now, of course, result is able to execute now because math.sqrt is now available as I imported math, and I can do this result as well. With math, we have opened a whole new Python world. I'm going to go to Google and search for math library Python. And as you can see here, the first result is this math in the context of Python. You can also call it module because this is a Python library that's already accessed when you install Python. If you want to call it module, it's the most correct term for beginners. I don't think it's too practical to mix the module and library because when we use pandas or numpy, we are also going to use import statements. So I prefer to use the library term for everything, okay? Now, as you can see here, the math has all these functions that you can see right here. We have the ceil function that will return the smallest integer greater than or equal to x. For example, if x is a float, we pass the ceil and it will return the next integer right after that float. We also have floor, which is the reverse. We have a lot of things here that we can use. I'm going to test some of these functions for you to see as well. I'm going to go there, and I'm also going to leave these in the resources for you to see in the future. But if I go, for example, here, math.ceil, and I'm going to pass 4.3, this will return 5, which is the next integer after 4.3. If I pass math.floor and pass 4.3, this will basically give me 4, which is the integer that comes before 4.3. So we can use all these functions, and also I'm going to leave this in the resources for you to experiment with these functions that we have available here. Another thing that we can use with math is, for example, math.pi, which will give me the pi number. And notice that this is not a function because we don't use any parentheses to call this function. What we do is retrieving the attribute, and inside this library math, we have the pi stored as 3.14, 15, blah, 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 so and so on. So this really, really long number with a lot of digits. So we also have other functions, for example, math.log that we can call. Now, something that you may be wondering, if you are aware of how the logarithm works, you may be thinking, well, what is the base that this logarithm is using? We can check any function documentation, at least the ones that are more famous and that we can use with libraries, using help. So I'm going to pass help math.log. This will give me documentation for the function logarithm that comes from the math library. Now notice, we have a log x, and then we also have a base. So x is the number that we are applying a logarithm to. And then the base, by default, is math.e. Okay, but we can specify another base by specifying a new argument in our function. So our function here has only one argument, by default, and this enters by order. We'll get there in a couple of moments with the order of the arguments in the function. Don't worry too much about it for now. Now, by order, I can pass a new argument, which is the base. For example, if I pass a 10, this will be a logarithm of 10 base 10. So the functions are not restricted to only one argument. We can pass multiple arguments inside, and these functions are able to support multiple arguments as well. So very important in this lecture, what we've learned is how to import libraries that have external code, how to call functions from those libraries. We've also seen how to call some attributes that are stored in those libraries, such as pi. And finally, we wrapped up by checking the help function to call some documentation on functions and everything that we want. And then we've also learned that we can use multiple arguments in a function using a comma. For example, here we are calling math.log, first argument, a comma, second argument, and we've seen by the documentation that the first one is the number that we are going to apply a logarithm to, and the second one is the argument that contains the base of this logarithm. Don't worry if you don't master logarithms, because it's not important for this course, and it's just a way for you to understand that there are multiple arguments that we can feed into functions. We'll see this with more detail when we get to the functions part, where we will also learn how to code our own functions. Okay, we are done with this math library that was very, very important. Let's continue with our study, and next we are going to see why strings are so important and how they differ from applying these mathematical operations that we've seen here. I'll see you in the next lecture. Hi everyone, welcome to this Python quick course. Okay, so we've seen here how we can use Python as a calculator, right? And how interesting it was to manipulate all these numbers and save things into variables. Now, one of the other important data types here in Python are the strings that I'm going to go here and put our string variables. Now, string or characters or text or whatever you want to call them basically represent free text here in Python. And how we can declare a string is basically in two ways, either passing single quotes or passing double quotes. Oops, put it here, double quotes. Everything that we put inside these characters, either the single or the double quotes, will be interpreted as free text here in Python. I'm going to save a new variable called my text, which will be basically just salute saying hi Mivo. Okay, so this is text that will be interpreted and that I can print later, of course, using the print. There you go, just printing text here on Python. Now, strings are very important for several things. So strings are the first case where we can index elements. Indexing is not exclusive of strings, of other more advanced data types and structures. We can also use indexing, but strings are very good for us to explore that concept as well. First, before going there, let's see how strings behave, for example, when we apply a sum to two strings. Let's see what that means. When I go here, my text plus my text, what do you think will be the result? In Python, this performs a concatenation. This is not usual, okay? Python, I think it's one of the first programming languages to do this, or at least one of the few that do this. For example, R isn't able to sum two texts and will throw an error. Python assumes that when we sum two strings, we are basically concatenating them, which is kind of handy. But just because these are strings, we are restricted with certain things that we can do with them. Just like we are restricted with numbers also as well on other instances. But for example, let's try to apply, I'm going to import the math and do math.square root of ABC. Let's see what this will yield. So as you can see, we have an error because it makes no sense to apply a square root of the text ABC. And Python is giving us that here on the type error, saying that for the square root to work, we need to pass a real number and not str. Not str, where can we get the str? By passing, for example, type or ABC into the type function, we get in a return str. And again, very, very important for you to master the Python language. The data types that these objects have are what determine what types of things we can apply to them as well. So the operations that we can do on these data types. Okay. Another important thing with strings, as I've told you, is that we can index strings. Let me return to my salute here, or my text. And now, let's imagine that I would only want to retrieve hi. Well, I can do that very easily using square brackets. When we have square brackets attached to a variable, we are indexing that variable here in Python. Notice that this is different from the parentheses that we've seen. Those parentheses are normally for other things such as calling functions. When we have square brackets, we are indexing. So indexes on Python start on 0. There you go. So if you code in R where indexes start on 1, it's maybe a bit confusing at first, but then I think you'll get used to it. Now when we have my text 0, we are indexing the first letter. If I want the two letters that I have there, let's see if this will work. 0, we have 2 dots, 1. The 2 dots, when are inside of a string, are normally read as until. So we are indexing here my text from the 0 index first character until the second character. But let's see what this will yield. It only yields h, because there's a part of that index that I didn't tell you. Basically, what that translates to is from index 0 up until 1. So the 1 is not included, the index 1. If we want to include index 1, we need to put 0 up until 2 in these indexes. And in this way, we retrieve the first two characters, index 0, index 1. What I've done with this colon is doing index slicing. Slicing basically means just retrieving multiple indexes with one instruction. So here I can also do singular indexes, as we've seen. For example, if I pass 2, I'll retrieve the third character of this text. Now notice, what's the third character? Let me go here. 0, 1, 2, index 2, third character is the comma. So we have in the return the comma with my text 2. If I pass 3, for example, index number 3, fourth character, let's see what this will yield. Or before doing that, check the my text. I'm going even to print it here. And can you guess what we will have in the return? Pause the video for a minute and then we can continue. Okay, assuming you pause the video, let's see. We have a blank space, because blank spaces also count as characters here in Python. So this blank space, the space that I'm giving between the comma and I, will also be included as a character. Now something very important is that we can continue until the end of the string with these indexes, but if we try to retrieve an index that doesn't exist, for example, there aren't 15 characters in this sentence, we'll have an overflow, basically index error, and Python will tell us that the string index is out of range. So the index that you are trying to retrieve from this string doesn't exist. And then Python is able to give us that. Another property of strings is that strings are immutable. They can't be changed. This doesn't mean that we can't replace them. It just means that we can't pick up a variable that contains a string and change some of their indexes. For example, and this will make much more sense when we study lists next. But let me put here, for example, text will be Europe. Imagine that I would like to substitute the last T for an A. So translate that to my language, which in Portugal you read Europa instead of Europe, and I wanted to make that translation. So if I go for text, and let's count together the index 0, 1, 2, 3, 4, 5. If I go for text 5, I'll get the E. Imagine that I would like to substitute this with an A. For example, assigning to this position an A. Let's see what we will have. We have an error, and basically Python gives us that property of strings that they are immutable, they can't be changed. One thing that I can do, of course, to change this string is replacing the whole text. But now I'm not replacing the string Europe. What I'm doing is completely redirecting the text variable to a new string called Europa. The Europe no longer exists because it's no longer attached to this variable text. Okay, I'm going to run this, and now if I print text, I'll have Europe in the return. Now this is a very important concept here in Python because it's very confusing for beginners. Some objects are mutable and some are not mutable or immutable. It is very important when you are coding because these errors will certainly show up and you'll be very confused if you don't understand these properties. Take your time to understand why this happens. I think it will be much easier to understand the immutability property when we see a mutable object, such as a list, which is something that we'll see in a couple of minutes. Now, before we go, there are certain functions that we can call on strings that we can't call on numbers. And there are two types of things that I want you to distinguish here. First, more general functions. For example, len. These are functions that we call like the print type and so on. They are called functions. And I can pass len and pass my text inside, and I'll get the number of characters that this string has. So in this case, the text right now contains 6 characters. The len returns 6 in the number. Now, one of the things that I would like to tell you is that I can't call len. For example, if I'm going to even call it text 1, 2, 3. This is not a text because I don't have any quotation marks around this 1, 2, 3. But if I call len on text, I have an error because this object of type integer doesn't have a property named length. There's no concept of length. But now one thing really interesting. What if I do this? If I put the quotes on the side of my 1, 2, 3, now I will be able to access the size of this 1, 2, 3 because it's no longer a 1, 2, 3. It's a text with the numbers 1, 2, 3, but it's never interpreted as numbers. So Python doesn't think that this is a number. It doesn't think that because I've wrapped it inside the quotation marks. Very important to know this. So anything that is passed inside quotation marks, although there are certain examples, for example, dates in some cases that may be wrapped in strings, but those are special cases. In general, everything wrapped inside these quotation marks will be interpreted as string, type str. Just before we leave, let me just do an experiment. For example, I'm going to do print text plus text. If I have text with 1, 2, 3, I'll have a concatenation of 1, 2, 3, 1, 2, 3, because this is a string. But if I take out the quotation marks from each side, I'll have 246, the mathematical operation. Python was able to distinguish these two operations by what? By the type that this variable text contains when it is going to apply the calculation. So for example, I can do the following. I can do this now and check the type of my text, type text, integer, and if I pass some quotation marks here on the side, 1, 2, 3, 1, 2, 3, the type is string. It's by looking at the data types that Python is able to decide what it will do with the variable we apply this sum sign. Okay, I think that's generally it for now. I think this we've done here a good overview on strings. Now we've seen the most basic data types in Python, which are basically strings, integers, floats, and we also touched a bit on booleans with the true or false values. Now let's continue and understand how we can work with other types of more advanced data types, commonly called also data structures here in Python. And here in the next lectures we are going to learn 4. Lists, dictionaries, tuples, and sets. These are 4 ways that we have to organize our data, and these numbers and text that we've been seeing right here that are very cool to know here in Python, and we'll check them in more detail in the next lectures. I'll see you there. Hello everyone, welcome back to this Python course. Okay, I've cleaned my entire working notebook to make it a bit easier for us also to focus on the next couple of lectures. So if you want, you can just clean the entire notebook by selecting the cells. If I have here, for example, 1, 2, 3 plus 1, 2, 3, and then ABC, you can select all the cells using Shift and clicking on your mouse, and then you can edit, delete cells. This will clean your entire notebook. If you want, no need to clean it if you are doing at the same time as I am, okay? This was just a way for me to have like a different focus in these lectures. So lists are very, very important here in Python, and they are one of the most flexible ways that we have to work with the language. So lists are very interesting because they can collect different objects of different type without changing the underlying type. Let's see what that means. I'm going to do here a MyList example, and lists can be opened using the square brackets. Now, don't confuse these square brackets with the square brackets from the indexes. The difference is that these square brackets have an equality sign before. That means that we are assigning something to MyList, and in this case, when we don't have anything right next to the square brackets, that means that we are creating a list. When we have something right before the square brackets, then we are indexing the object. And we can index lists, as we will see. But now, let's create here several elements on this list. This will be a pretty basic list that will contain the number 1, the number 2, the number 3, and the letter A. Now, one thing that is very, very important, notice that I'm giving new elements to my list by providing a comma. The comma is what enables me to give multiple elements to a single list. In this case, this MyList that I have here will have stored, as we will see, I'm going to run this. I've allocated these values to my list, and I'm going to print my list. So the my list contains now 4 different values. It contains the number 1, the number 2, number 3, and letter A. Now, as you may notice when I've printed this list, the last element contains single quotes. And that's because this element is still a string. Okay, it didn't change into any number just because I have numbers before. That's a very, very interesting thing about lists. Now, how can I index a list? Well, I can index a list using, for example, my list, opening square brackets next to my list. I know that this seems confusing because we are using square brackets for 2 different things. We are using square brackets to create the list, and we are using square brackets to index the list. But the main way for you to understand the difference between these 2 things, when creating a list, again, we don't have anything right next to the square bracket. While when we are indexing, we have immediately an object normally. Okay, so here if I want the index number 1, can you guess what this will retrieve? Pause the video and see if you can do this for yourself. Okay, now let's see. We have, of course, number 2 because it's the second position, index number 1. Remember, indexes on Python start on 0. Okay, so if we have number 1, let's see if we can get, for example, my list 1 plus my list 2, 5. Why is that? Because we are summing 2 and 3. Now, this code that I have right here, and this is a very, very important thing in Python, is exactly the same as having this. Let's see. I'll provide here 4 alternatives, even with a print, so that you can have multiple instructions. So, print my list element 1 plus 3, exactly the same result. Print my list, this disappears, 2 plus my list 2 equals again 5 as well, and as we'll see, 2 plus 3, this will all yield the same result, 5. So the idea behind this is that when Python is performing any type of calculation, it will substitute what the object contains, just like it has done in other objects. When we had the calculations done on variables, this was what Python was doing. It understands that my list square brackets 1 should refer to the value that is stored on my list, and it will substitute the value from that position, which is 2. Okay, so this is exactly the same as 2. The difference is that we are using a Python object to obtain these 2, and we are not doing the calculation directly with the 2. Okay, hope this was clear and that you could understand why these are equivalent. The difference is that in some of them we are using Python objects, in others we are doing number calculation directly, okay, without using variables. Also, here in lists, what we can do is something that we couldn't do in strings. If we can index this object, can we change it? Let's see. So for example, imagine that I want to change the 3rd element to a B. Let's see if this works. It did work. So lists are different from strings. Strings are immutable, lists are mutable. They can be changed. If I print my list here, I have now 1, 2, B, A. The 3 was replaced by a B. And this was enabled by Python just by assigning a new element to that list position. Very important to memorize. Lists are mutable, can be changed. That also makes that we can call certain methods that are very, very cool. I'll do a parallel here. Instead of continue to speak about lists, I'm just going to speak about methods that are tied to an object. For example, let me go here and put text is equal to Europe, as we've seen before, where we couldn't do this, remember, right? Because the string object type does not support item assignment. It's immutable. But there are certain things that we can call on top of our strings that I didn't show you. For example, we can call the replace method on this string. And the replace method, it's very interesting. I can even go here. Let's also have this habit of checking the documentation. So basically, it's a built-in function that we can use that basically replaces a copy of the string by replacing all the occurrences of substring old with new. So I can go here and do old is equal to E, new is equal to A. And this will replace the Europe string with Europa. Two important things. We are replacing this using a string method. And methods are called by having the object, providing a dot, and then calling a method on top of that object. This will act on the previous object. It's similar to functions. Remember that functions, we do, for example, this. This is a function, print text, right? And a help is also a function. Let me delete it from here. So this will pick up text and use this as an argument for the print. What we are doing here is as if we were doing this. Replace, imagining that the string would be the first argument, we will be doing something like this. But in Python, we have the method syntax where we use the object and then we pass a method that is like a function. It will act like a function, it will take arguments, it will return elements, but it's not a function like we call it normally. It's a function that it's connected and tied to the object type. Okay, so this is very important because we can only call this replace inside string objects. If I try to call replace, for example, on, let me go here and put number is equal to 1, 2, 3, and then try to pass, for example, replace 1 by 2, the int object has no attribute replace. There's no way to access this attribute. An attribute here takes the place of method, but what Python really tells us is that we can't access this method. Okay, so this method, the replace, is only accessible by string objects. By string objects, just like in certain functions, we can only call them on certain types of objects. I hope this was clear. In the quizzes, we'll also have ways to practice this and also to understand how we can work a bit better with these methods. Now, notice something. When I call text.replace, what we have right here is that we get back Europa. That means that this is a new string that I can even call. For example, new text will be Europa because text.replace returns a new string because strings are not mutable. So if they are not mutable, the only way for this replace to work is to redo the string by replacing the characters and then returning a new string. It can change the original string. As lists are mutable, when we call methods on lists, they don't return anything. They change the object in place. That's what we normally call the in-place operation. And I'm going to show you what that is. So in my list, I'm going to pick up the list that we had before just to make it even easier. We'll go here, my list. I can call, for example, my list.append, and I'll pass a b. Now, what I'm doing here is calling the method append that is connected to the object type list or to this data structure, and it can only run here because my object is a list. Append method is only accessible by these data types. If I run this, something interesting will happen because it will be a bit different from the replace. There's no return. Why there isn't a return? Because the object was changed originally. If I now call my list changed. When I call replace here, I'm going to return to the replace. And I do this, I run again new text. So the text, the original one, didn't change. It's still Europe. But the new text is the one that is Europa. But now if I call my list.append, the original object is changed. This is because of the mutability property of lists. Now, you may also ask, why don't we have a mylist2 or a new mylist to keep the syntax? And run this. Let's see. And now if I check new mylist, it doesn't contain absolutely anything because this operation doesn't return anything. What this operation does is changing the original object. If I try to print new mylist, I have a none, which is Python way of telling me I don't have anything in this object because these list methods change the original object. They don't return anything. They just change the original object. Okay. Hope this was clear in terms of how Python works with methods as well. I know that this is a bit confusing for starters, but Don't worry, because with more exposure, I know that you will master this concept. What's more important from this lecture is that you understand that methods are also tied to the objects that precede them. So when we call a method, normally that method is accessible because of the object type that we are calling, and then depends on how they work with the object. If the object is mutable, they change the original object. There's no return. We can't return anything to a new variable. If the object is not mutable, meaning it's immutable like a string, these methods will return a new element and we'll have to assign it to something else. Okay, so very cool. We have here a new data structure, which is the list. We also seen how we can call methods on this type of object. Let's continue and learn another interesting object, which is the set object. Let's see that in the next lecture. I'll see you there. Hi everyone, welcome back to this Python course. Okay, let's learn a bit about Python sets. They are basically very interesting for us to get like distinct elements of objects. So sets can be written with curly brackets, and when there are no colons inside those curly brackets. You see why I'm saying this in a couple of minutes. So I'm going here and call my set and saying 1, 2, 3. So my set is a collection of distinct objects that I can use in Python. For example, sets can only save distinct elements. For example, 1, 1, 2, 3, the resulting set will be only 1, 2, 3, because as 1 is repeated, it is collapsed into a single element. This will happen with all repetitions that I may have here. I'm going to repeat 2 and 1 a lot of times. The set will not change at all. Sets have some peculiarities, so they can't be indexed. If I go here and try to index a set, I can't do that like I do in lists, but I can convert this set to a list and index the object. Now, sets are not ordered by default, and this is very important. When you convert a set to a list using the list keyword, as I'm doing here, so this is a very interesting function as well. This function basically receives an object and translates it into a list. Okay, this will create a list, but using a specific object that we pass into it. But there's no guarantee that this set will be ordered. This set right here is just ordered by coincidence. If I go here and pass, for example, -1, -2, and run this, and now go to list my set, as you notice, this is not ordered. There's 1, 2, 3, -1, -2. So this is a bit of a bummer with sets, because when we try to convert them to lists to index them, we lose that property of kind of order in the set. Although when we see it, Python orders it, underlying they are not. This is a bit confusing, but just want you to know this property. So sets are very valuable for also one thing. When we have a list and we want to extract the distinct elements of that list, it's very, very cool. For example, I'm going to use here a list, which is a basket of groceries that will have banana, apple, another apple, and another apple, and also milk. And we wanted to know what were the distinct elements of this basket of groceries. What we can do is call the set function. Let's pass our basket of groceries inside this set function and see what this will return. So as you can see, we have apple, banana, milk. Okay, let's continue for the next lecture, where we are going to speak about Python dictionaries. I'll see you there. Hi everyone, and welcome to this Python quick course. Okay, so here in this section, what we are going to do is learn about a new data structure called the Python dictionary. The Python dictionary is a really, really interesting one that gives us here a lot of flexibility regarding Python code. I'm going to put it here, Python dictionary. So the Python dictionary is basically a key value pair oriented structure, and I'm going to show you what that means. So basically, we can use the curly brackets, and we can also use this to create sets, but the difference is that when we have the following way to organize the data inside the curly brackets, we are speaking of a dictionary, namely in the following way. A key, and here I'm going to say, for example, John, and then a value, and I'm going to say 25. Imagine that these are the ages of some people, and here I can pass a comma, pass a new key, for example, n is equal to 20, and then new key, for example, Joe is equal to 24. So when we have these colons inside the curly brackets, we are speaking of creating dictionaries. I'm going to save this in a variable called myDict and run this code. Now, dictionaries, if I go here and see type myDict, basically this new data structure called the dictionary, it has several ways for us to access the values and the keys. Mostly, one of the most famous is to call the dictionary and then with square brackets, just like we index the other objects in Python, we can pass here inside the key. And in this case, if I go here and pass John, I'm going to retrieve 25, the value of John. So this is a very, very neat data structure that we can use to access values from certain keys here in Python. And this type of data structure is very, very cool. There are three important properties for dictionaries. If I call here myDict.items, I'll have as a return a tuple of the key values. This tuple contains then key value pairs that we can access. Then we have also myDict.keys, which will retrieve the entire keys of the dictionary. And also we have myDict.values, which is these values that we have right here. So in the case of the list of tuples that I've said before in the items, that's the next data structure that we are going to learn, which is the Python tuple, which is the last one that we are going to learn before going for other stuff. Here, just want to show you this key value pair oriented type of data structure, which is commonly used in Python, and it's one of the most flexible data structures that we can use here in the language. So next, let's learn about Python tuples. I'll see you there. Hi everyone, welcome back to this Python course. Okay, so in this lecture we are going to learn about another data structure, which is the Python tuple. The tuple is a very, very simple object that we can use by providing the parentheses with something inside. Tuples are basically data structures that are kind of similar to lists. For example, I can have a tuple of numbers 12, 12, and 23 and give here my tuple. Okay, so in this way. Let me also zoom in this a bit. Okay, so here in my tuple, for example, now I have this object, which is kind of similar to a list. The main difference between tuples and lists is that tuples are not mutable, just like lists. For example, if I try to access the second index, third element of this tuple, I'll get 23. But if I try to change this, remember that this is enabled in lists to, for example, 22, I'll have an error because tuple object does not support item assignment, just like strings and as we've seen in strings. So this is an interesting data type that we have here in Python, and the main idea behind them is that if you don't want to change the underlying objects that you have on a specific data structure, a tuple is a very good way of storing those objects. Also, tuples are a bit faster than lists to access and to write, just because of that immutability property, meaning that they are not mutable and we can change them in place. Now, this is basically the Python tuple. They are indexed just like lists. All the things that we've learned about indexing lists apply to tuples. This is the last data structure that we will see in the next section or in the next couple of lectures. We are going to deal with more interesting concepts here about the language, namely how we can control the flow of our code and how we can develop our own functions. So I hope you are enjoying this Python quick course, and I'll see you in the next lecture. Hi everyone, and welcome to this Python quick course. Now we are going to learn how we can control the flow of our code. And here mainly we are going to learn two types of instructions. First we are going to learn the if instruction or the if-else clauses, and then we are going to learn the for and the while loops, which are three of the most common ways for us to deal with Python control flow. So I'm going to go here and I'm going to do the following. I'm going to mark down and say Python ifs. Okay, this is part of control flow. So Python ifs are very, very simple. Oops, let me just give here an extra blank space. So Python ifs are very, very simple. They basically have the following way to work. I'm going to give here rain, and I'm going to say, I can even be more clear, yes or no. And Python ifs can help us choose which path our code is going to take. For example, they are very simple. If rain is equal to yes, remember equality has two equals, assignment has one, this is very important, we give a colon and we do an enter. Notice, this is very important in the language. Where my cursor is right now is indented one space. That is because indentation controls the flow of the code here in Python. Everything that is indented after this instruction and after this colon is dependent on the code that we see above. And here I'm going to do something which is print take an umbrella. Okay, so this is going to be how our code is going to behave. But I can also give other stuff. For example, else print do not take an umbrella. Okay, so now our code will go through two different routes according to the thing that we have here. If rain is yes, we are going to run this block of code. If rain is any other thing, we are going to run this block of code. Okay, so let's see what will happen. I'm going to run this, take an umbrella. Now let me change this to no. Do not take an umbrella, because the code is not going through this route, it's going through the else. Basically what Python does is evaluates this instruction. If it is true, it's going to go through this one. If it is not, it's going through this one. Okay, so I hope this was clear. These are basically if statements. We can fit in this condition anything that we want. Now, one of the important things that we need to assess is the fact that there also exists another clause here, which is the elif clause. For example, if I write here banana, I will also have do not take an umbrella. This does not make sense. We only want people to write yes or no to the question that we see rain, or to the variable rain. So what I'm going to do is, instead of doing an else, which will basically catch anything when rain is not equal to yes, I'm going to give another explicit condition, or a clear condition, elif rain equals to no, and here I'm going to print do not take an umbrella. Now Python will do the following. We'll look at this condition. If this is not true, we'll look at another condition, which is used with the elif from else if, and if both of these conditions aren't true, then it's going to go for the else. I can close the for here. Nothing will run because none of these conditions are met. Let me run this. There's no print, but I can also go here and do else print please provide a valid weather status. Okay, now when I run this, banana will go for the else, which catches everything when rain is not equal to yes and rain is not equal to no. Now if I do yes, take an umbrella. If I switch by no, do not take an umbrella. So that's basically how Python conditionals work. Okay, very important. We have mostly three rules: if, elif, and else. And remember, indentation here controls the flow of the code. If this block is indented, that means that it depends on the code that we see right next to it. We can have multiple instructions here, for example, print something else. Okay, these two lines of code right here depend on the if rain is equal to yes. They depend on what we have right here above. Okay, it's basically a way for us to control the code here in Python, and using these if and else, elif and else statements to control where the code will go, basically. And as you can see, we have here these indented blocks, and these indented blocks are very, very important because they are the ones that enable us to state which code depends on what. Okay, I hope that this was clear. This is also a cool way for us to control the flow of the code. Next, we are going to learn for and while loops, two other important parts of the control flow here in Python. I'll see you there. Hello everyone, and welcome back to this Python quick course. So now we are going for Python loops. So Python loops are very, very important for us to iterate through a specific object or to iterate through a specific condition. So what I'm going to do is here just write a list with student names. Okay, so this list will have Anne, Joe, and John again. Imagine that I would like to iterate through this list and greet these students in my class. How can I do that? Well, I can use Python for loops for that. So this is very simple. For student in student names, I open the colon again, there it is. This is a very important part of the control flow. I press an enter, and then here I can do print hello, and then a plus student. Okay? What this will basically do is run this code, the print hello student, and notice that the indentation is here again, because this statement depends on the for loop that we see above. And what we are going to have is print hello N, print hello Joe, print hello John, because we'll start one at a time. Okay, let's see that happening. There you go. Hello N, hello Joe, hello John, because we iterate through every element of my list. And this is what for loops are doing in the background. Now, another really important thing, this student right here is just a placeholder. This can be an I, it will work exactly the same. The only rule is that the for, what is here in the for, must also be the same thing that is referenced below in the code that we see right below. Okay, so the code that depends on the for. I hope this was clear. This is how we do for loops on objects. I can iterate also on, for example, tuples. Imagine that this would be a tuple. It will work exactly the same. We use the for when we know typically an object where we know where the end is, okay? When we have a way to understand that. There's another type of loop that we have here, which is the while loop. Now the while loop is more dangerous because basically with the while loop you can put an infinite loop in place that will basically toast your computer, and you'll notice because the loop will never end. But while loops are based on certain conditions. We'll evaluate something until something is no longer true. For example, imagine that n is equal to 1. While n is less or equal to 10, I'm going to print yes, it's a random thing. Now, if I run this, this will never stop. That's why I'm not going to run how it is right now. Because n will never be updated. N will always be equal to 1. So as n is equal to 1, n will always be less or equal than 10. So I'll have yes, 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 and so on. So what I need to do is inside the loop, I need to update my n by giving the n that is there plus 1. So basically, this n will pick up whatever n we have in this variable, whatever number, and adds 1 to it, replacing that n again. That means that I'm going to even put here plus n, just for you to see yes 1, yes 2, yes 3, and so on. Let's run this, and oops, I have an issue. I can't apply a concatenation between strings and integers, of course. So I'll convert this n to a string by passing the str function. Now we have yes1, yes2, yes3, yes4 until yes10. What happens is that when Python updates this n to 11 and evaluates this while loop again, 11 is not less than or equal to 10, and then the loop stops. The loop will only stop when this condition is evaluated to false. So be really mindful when you use while loops, because you can generate an infinite loop in there and your code will never end, basically. Okay, so I hope that this was clear. Let's continue and learn a bit more how we can create our own functions in Python, a very, very important component of the language, and what we will see in the next lecture. I'll see you there. Hello everyone, welcome again to this Python quick course. Okay, so here in this lecture we are going to learn a bit about Python functions and how we can use Python functions to make our code a bit more reusable and also a bit more flexible. Okay, so I'm going to write here Python functions, and we are going to use the notebook for functions that you will see in the folder. Okay, so this notebook functions. So this notebook functions right here. We run this and zoom this in a bit. Okay, so Python functions are a very, very cool concept that we can use to have our code being reused several times. This is pretty easy. So basically when we call a certain function, for example, the type function that gives us back an object type, that underneath that is a Python function. That is indeed some function that is already pre-developed for us to use. So we can also do our own Python functions using this def from define keyword. So the def keyword will let me write any type of new function, and I'm going to do here something called simple function, and I can open parentheses and close parentheses to let Python know that I'm creating a function along with the def keyword. We'll see what will go inside these parentheses in a bit. Again, we use a colon after defining the function. Probably you know what will happen when I click enter. We have an indented block. This is the same as we've seen in the control flow when we see, for example, in ifs or fors or while loops, that the code that goes indented next to the instruction depends on an instruction that is above. In this case, the last instruction with the colon. Here is exactly the same. So this function that I have right here will just have something, which is a greeting saying hello. Super simple. Now, if I want to retrieve something from this function, I need a new keyword that we are going to learn, which is the return keyword. This enables me to do some operations inside the function and return some type of object from the function itself. In this case, I want to return greeting. So basically, this function will run and return always the same thing, which is hello. Doesn't make much sense, but for this small exercise, it will be easy to understand. So after I run the code with the def keyword, I'm basically saving this function to be able to call it later. Okay, so I've run this def simple function. That means that I've defined this simple function that I can run now using this syntax that you're probably familiar with. When we called other functions, we used exactly the same thing. So if I run simple function, I have in the return of the simple function the word hello. But of course, if we are always running the same thing, that takes out the argument that functions can be reused, right? So that's what we are going to do next. I'm going here for the simple function and I'm going to say hello and here plus name, right? And then here I'm going to put name inside these parentheses. So basically what I'm now doing is that when I run this function, I can call an argument. Just like when we call certain functions and use arguments inside our function. That's what we are giving here. And this was very simple. We just added the new argument inside the name. Now let's see what this will give. I'm going to give simple function and I'm going to try to call the simple function again, this one. And you'll see we'll have an error because now simple function is missing one argument. Of course, if we've defined the simple function, and let me just return to say something, which is when I've written this again, this def simple function, I basically substituted what was on this simple function, what was being executed with this simple function. So rewriting the code, erase the idea that Python had of this code, the greeting and return the greeting, and substitute with greeting hello plus the name that comes in the argument. So here now Python is telling me, hey, in the simple function, you basically defined an argument. I need to know what that argument is. Can you please provide it? How can we provide it? Super simple, we just provide it. Here, when we are calling the function or executing it. So two important steps, defining the function and then call it by its name. Okay, let's run this again. And as you can see, hello, John. Although we have no blank space, let's give that blank space. I'm going here, give an extra blank space. And now, if I just do this, will the simple function be with the blank space there? Let's see. No, because I didn't execute the def keyword again. I need to execute this again. I'm doing this with the shift enter, but you can also go here and do run. Okay, so only after I run the code that I'm changing with the def will this work. So now simple function, hello John. Now this makes much more sense. So one last thing regarding functions. We have here these functions. We've done a function with one argument. I'm going to copy the simple function. I'm going to say not so simple function. I'm sorry, this is an awful name for a function. So here I have a single argument, but I can have more than one argument. For example, here I'm going to give an extra argument called lecture. And I want to say plus, I'm concatenating the strings, hello, name, plus, welcome to the, plus, lecture, plus, class. There's much more efficient and easier ways to do this, namely with f-strings or dot formats. I'm not going to do it right now so that I'm not confusing you. That's why I'm doing this with this concatenation here, okay? If someone that already is proficient in Python is on that side, don't scold me right now because I'm doing this on purpose, okay? So let's go not so simple function. Now, what we can do is pass. For example, let's try to pass Joe here. We'll have an error because not so simple function requires another positional argument called lecture. I didn't give the lecture. And I'm going to go here and say new argument. How do we give the new argument? Just like we give in other Python functions, providing a comma and then passing the new argument. And there you go. Hello, Joe. Welcome to the Python class. Okay, very important in this lecture that we've learned, defining functions using the def keyword, running those functions, and also how we create arguments in our function that we can call later. Okay, very cool. I'm going to save this and That's it. This is our basic introduction on Python functions. Play around with these functions to see if you can also create some cool stuff, and also check the notebook where we have some more examples that you can follow to get a bit more familiar with this concept. Okay, so we're done with functions for now. Let's finish this course by looking at two libraries, two of the most famous libraries here in Python, numpy and pandas, normally used in the data analysis field. That's what we are going to see in the next couple of lectures. I'll see you there. Hello everyone, welcome back to this Python course. So here in the last couple of lectures in this Python quick course, on the section of this Python quick course, we are going to learn how to just basically work with two important libraries, numpy and pandas. These two libraries are commonly used in data science and analytics setting, so let's learn how to work with them. I'm going to go here and use numpy for starters. Okay, so mark down numpy. Okay, so remember, to use these libraries you need to have them installed in your environment. That's mandatory, okay? So the environment that I gave you in the course materials and that we've learned how to install contains these libraries already. If you started an environment on your own, go back to the lectures where we learned to install libraries so that you can also work with them here. Okay, so just like we've done with the math library, here we need to do something. So importing this library, okay? And here I'm doing something new, which is using this alias asNP. This asNP, basically every time we want to refer to numpy in our scripts, we can use this np instead of always writing numpy. Okay, so I'm going to execute this and run, and now we have basically numpy available for us in our notebook. If you close the notebook or in some way restart here the kernel, for example here, and do restart, remember that you'll have to import the library again so that you can access the functions. Okay, so numpy is a mathematical library that enables us to work with vectors, matrices, tensors, so basically mathematical objects, and is very, very cool to use here in Python. To start, I'm going to create a really simple array that contains only the value 2. Okay, so this is the example of an array. It's an object similar to a list, but it can only contain elements of the same type, in this case integer elements, as we are doing here. Let me create an array with 2 elements, which will be kind of similar to a list, and I'm going to pass a list inside the np.array function, and I'm going to call this the myArray. Okay, so myArray. So this array has 2 elements in a single dimension. How we can check that is using the shape attribute from the array. Notice that this myArray, although we are now looking at a new object, we call type myArray, we get in the return a numpy.endArray, means that this is the type of this object that we are seeing. Now, indexing arrays is just like we've done in indexing lists. For example, if I go here, myArray, and select the element index 0, I'll retrieve the value 1, which is this value right here. I can also print my array here below, and you'll see that we are indexing just like we index lists. This is index 0, this is index 1. Now, one new thing that we can do with arrays is create multi-dimensional objects. That's what I'm going to do here. And I can do that by passing a list of lists. For example, I'll wrap this up in a new list, I'll do a comma, and I'll pass a new list right after. So now my array will have 4 different elements, 1, 2, 3, 4, okay? And this myArray is a multi-dimensional array. It will contain 2 dimensions. And let's see what this means when we now check the shape. So notice that now we have 2, 2. The number of elements in this tuple that contains data, that contains numbers, define the number of dimensions of our array. In this case, we see 1, 2 elements in this tuple, so that means that our array contains 2 dimensions. How many elements does each dimension contain? 2 in each one of them, right? 2 and 2. For example, if I do here, if I add here, I'm going to add a 10 and a 10 here, and now run shape again. Basically the second dimension, which is the columns of this array, and you'll see that contains 3 elements. So let's now see our array. So this created basically a shape similar to a table, similar to a 2-dimensional table, right, with rows and columns. Look that these are the rows, 1, 2, 10, and this is also the second row, and these are the columns, 1, 3, 2, 4, 10, 10. Now, you may be thinking, how can I index these multidimensional objects? This is probably not trivial, right? And luckily, it's very similar to how we index unidimensional objects, such as lists, arrays, and all that. Do not confuse multidimensional with multi-element. Multi-element means that we can have multiple elements inside those objects, separated by commas, for example. Multidimension is a bit different because in this way we are orienting the data into rows and columns and gives us another view of the data. Okay? And here, for example, in this array, now I can index. In the first position, we have the index of the first dimension, so this will index rows, and now I can pass a comma to index things on the second dimension. Okay, so let's imagine that I would like to retrieve 2 in this array. That should be pretty easy because what's the row? It's the first row, so index 0. What's the column? It's the second column, index 1. So I can put here a 1. Right to the comma, we are indexing columns. Left of the comma, we are indexing rows. And if I run this, I'll retrieve a 2. What if I want to select an entire row? That is easy. I just have to leave one of the sides as blank, and this will retrieve me the entire row. If I want an entire column, that should be easy as well. We remove the index from the rows and index the entire column. Can you guess what this will retrieve? Pause the video for a moment and see if you can do it. Unfortunately, I've done here a bit of a trick question. Now, when we are indexing columns, this won't work, okay? So Python isn't able to support this syntax. What we can do is that instead of leaving blank, we can put a colon to indicate that we want all the elements. In this case, we are retrieving 1 and 3, the values from the first column. I hope this was clear, and sorry for tricking you a bit. Now, of course, this also happens if we do it in this way, okay? But when we are just indexing the first dimension, this can leave, okay? So we can leave it blank. This is a special scenario. Normally, we need to provide the colon to indicate that we want all the elements from that specific dimension. Arrays can go until the nth dimension, so they can have 10 dimensions, although they will be extremely hard to visualize when we get to more than 3. Okay, so experiment a bit with these types of objects and see if you can do some operations on top of them. This should be pretty fun to work with, and also check the documentation of the official NumPy library so that you can get a bit more familiar with this type of object. Now, arrays have an issue. We can't really label the elements that we have. For example, we can't label our rows and our columns. That's something that we can do with the next library that we will see, which is the pandas data frame, one of the most important libraries for machine learning and data science. Let's just have a 5-minute lecture on that so that we can get familiar with how they work. I'll see you in the next lecture. Hi everyone, and welcome back to this Python course. So let's now just look a bit into the pandas library, which is another famous library here in Python. And normally when you see the pandas library imported, you will see import pandas as PD. It's a very common way to state this library here in Python. Now we've seen arrays and how we can work with multidimensional objects such as arrays, right? With rows and columns. Now pandas is a bit more cool to work with these types of objects. For example, I'm going to pick up our array, the my array that we have here, and I'm going even to pick it up in this way. Okay, let me pass this into the pandas.dataframe object. Okay, this one. And as you can see, this creates me this structure that is much more visual to work with, which is the pandas data frame. This is very similar to an Excel file, of how we see Excel files, and also very similar to how we see tables in SQL, for example, or tables that are in databases. Now, we can call extra arguments on this pandas data frame. Let's also check some documentation on this PD data frame function, right? Which is basically this function that takes a lot of things, but I'm going to use data is the first argument. It's the one that we are going to use, this one. Now, I can also do something else. In Python, we can, for example, use the parentheses in our advantage so that we don't have a really long code. It's actually a best practice not to pass, I think it's 79 characters when we are doing Python code, so I actually like to use the parentheses in this way to separate the instructions. There's no issue at all in doing this. So now I'm going to do, for example, a new argument called columns, which will get a list with the column names, and I'm going to call col1, col2, col3. Okay, just making this up, and then I'm going to say index, and the index is the row names. So I'm going to say row1 and row2. and I'm going to run this one. Now notice, very cool, we have this new object that now has column names and row names. And this is very handy because it will enable us something else that we can do with these types of objects. I'm going to call here my data frame, okay? And I'm going now for my data frame, and I'm going to check something. So I'm going to use, let's see if we can index just like we've done with arrays, for example, 0, 0. Unfortunately, this doesn't work directly in a pandas object, but what it works is that we can call the iloc method from index location or locator. I'm not quite sure what's the origin of this loc, but I think it should be locator, location, I don't know. Well, never mind, let's continue. So with the iloc, if I do this, now I can retrieve elements from my data frame. Let's see. So row 0, index 0 will go for 1. And don't confuse row 1 with index 0, because indexes will always start on 0 regardless of what we call. And here I'll go for column index 2, which should retrieve 10. It's retrieving this number right here. Okay? Apart from this, we now can access something very cool, which is the loc. The loc let me pick up things by name, which is very interesting. For example, instead of 0, I can call row 2 and then call 2. This will be much easier to interpret because I want row 2, call 2. I'll get 4. Let's see. There you go. So the iloc and the loc methods are very famous methods that we can use to subset data from our pandas data frame. Okay. Other methods that I would like to explore with you here in the data frame are the following. So the head method, which I'm going to give add1, gives me the first n rows of the table. I'm just using 1 because we have 2. To make some sense of using this code, I'm just selecting the first row with add. And there's also the tail, which gives us the bottom of the data frame. In this case, going to give me the last row. There's also the shape that we've seen with arrays, works exactly the same. So pandas uses a lot of numpy in the background as well, so that's why some of the methods are similar. And now methods and attributes. Now we can use also something interesting. For example, if we call the len on data frame, we'll get the number of rows as well, which is something very interesting. Let's call just the type on our my data frame and see that this is basically a pandas from the core, but a pandas data frame, and this is a type of object. Again, the rule that we've seen that the objects define what type of methods and functions we can call them apply to these types of libraries as well. We know we have a pandas data frame, so we'll be able to call this add and tail because these methods are associated with the data frame object. If we call add or tail in a list, this won't work. Okay, so the logic is always the same. Okay, so this was just an introductory lecture on pandas. This was just for you to get a bit familiar with this library as well. Read the documentation of this library as well. And now let's go for the fun part of this Python quick course, where you're just getting a quick overview. Of course, it's impossible to master Python in 2 hours, but it's just for you to have a really quick overview. And the most important part is, of course, practicing. In the next lecture, I'm just going to explain you how you can do the exercises, and then you can continue and attempt them on your own, and also the quizzes that I've prepared for you. Okay, so I'll see you in the next lecture. Hello everyone, and welcome again to this Python quick course. So to do the exercises, just open this exercises Python quick course, okay? And in this one, you will understand how you can follow with the exercises that we have right here, okay? So these are the exercises that you need to complete. You can just read the instruction that you see here, then do your code where you have this your code here, substitute this by what you're trying to do. For example, I'm going to do this first exercise with you. Let's read it. Multiply the number 20 by the logarithm of the number 5 and store it in a variable named result1. So we can do result1 is equal, we are doing an assignment, to log of 5 times 20. Now something is missing here. Log doesn't exist without the math library. So if you want, you can go here and do import math and run this code. So in the end, you will do this for all the questions that we have right here. And in the end, you can run this validation exercise 1. Everything should run okay. At the end, you should have a message saying your code is correct. If that's the case, you got all the certs correct. Now, by some small tiny differences in the numbers or in the environment that you are working, you may have a situation where your code is correct, but the assert doesn't pass because of the decimal points. That's okay, you can consider that your code is correct. I'm not going to consider it invalid and you've done the correct instruction that you see here. You also have the exercise solutions here on this notebook that you can also check. So these exercises should cover the things that we've learned in this Python quick course, and I hope that you enjoy them and you find them fun. So I'm going to take this out now so that you have your code here. And in this notebook for the quick course, we have around 20 exercises for you to practice your first Python code, so I hope. Thank you very much for enrolling in this Python quick course. So if you are doing this in the context of some of my courses, I really hope you are excited to go there. If not, if you are just doing it on a Udemy platform where I provide this Python quick course for free, thank you very much for enrolling. And if you want, you can enroll in some of my other courses where I also teach Python, R, or SQL, things regarding data analytics and data science. So thank you very much, and I hope you enjoy the exercises. Okay, I just wanted to thank you for going through this Python free course. I'm giving this Python quick course as a way to get people an introduction to the Python language, a really fast introduction. If you are interested in learning other programming languages or learning a bit more of Python, just check out the bonus lecture where I have links for my other courses, such as my Python 16-hour course, which is of course an expanded version of everything that we've learned right here. Okay. I also have other courses such as natural language processing or even R courses where I teach other programming languages, but that follow the same teaching method that I followed right here. So if you've appreciated this course, I think you will also appreciate them. Again, thank you very much for enrolling in the course. It was a pleasure to have you here in this class, and I'll see you around. Thank you very much.